Good morning, gentlemen. Today I want to talk about traditional web application architecture and what are the things that can go wrong there. We have a browser here calling our web application on the back end. This web application uses a request response model, which refers to the traditional architecture. It depends on an API. This API can be provided by an external vendor or it could be an internal API consumed by our application. If it is an external system, this means other web applications, other systems are consuming it, and we cannot ensure the load that is hitting that API. Thus, it may, at any certain point, come into a status where it starts returning failed response messages. Because of, it is probably overloaded or having some issues there. This would lead usually our application to have partial communication failure and probably in many scenarios leading to our application failing and going down totally. Now we can, if it is an internal API, however, we can revert to scaling up the capacity of this API by having more memory, more disk space, etc., more specs, or using a load balancer here to launch several instances of this API in order to account for the additional load. Still, in this situation, we cannot be sure how much loads our application can expect to have. This means at a certain time, we may have thousands of concurrent users leading to launching several or needing to launch several API instances. And at some times, we may have few or 10 or 5 requests concurrent or less than that, leading to our infrastructure costing us several $1,000s without being justified. Now, what is the solution to this situation where our application depends on an external API or an internal API developed by other teams in the organization? Let's meet the producers consumers model or the queuing solution. What we usually do, we have the producer application to the left here, handing a message to the queue here, and continuing its operation normally without waiting for a response there. On the other hand, and at its own pace, the consumer service consumes that message and do the necessary processing logic. This leads to a decoupled processing of our function, operation, or our logic. Each component, as you can see, is running at its own pace without waiting on each other. Now the best way to explain this is taking an example with the email service. Here is our web application receiving a request from the browser here to send an email. The application simply logs this message into the queue. This message includes all the necessary information for sending an email and return to the user that we have received your request and you will receive an email shortly or something like that on the browser screen. The email service here at its own pace again collect this same message since it is always listening to that queue topic or queue channel, does the necessary communication with the external API or the SMTP server there in order to send the email. Now, in case this queue gets overloaded, we are talking about tens of thousands of emails hitting our queue, and a single email service, a single pod here, is unable to process all of these emails, is unable to keep up with the additional queue items or messages incoming. One solution is to scale out our pods, our email services. As you can see here, we have the email service, which is represented by consumer here. Here is a Docker pod consuming message 1. By launching a different consumer having the same code but sitting on a different Docker instance, for example, we can let two consumers consuming from the same queue here in order to process these messages in a faster pace. We call this scaling out. And when the queue becomes into a relaxed situation in a normal load status, we can then scale down by shutting down this consumer here in order to save some cost. One last thing related to queuing is that in order, for example, if you have a billing service here, let's say we received a request from the user for us to process some payment on his behalf. Step number 1, a queue item is created, let's say payment requested queue. The billing service will be consuming or listening to that queue, always listening to consume that message, then communicate with the external payment gateway to issue the payment transaction reference. Then it has an additional responsibility here in this case is to produce the response with all the necessary information related to the user payment transaction details. It can log this into the payment completed queue. Then this application has to always listen to that payment completed queue in order to send, for instance, an SMS or a push notification for the concerned user. In this case, you can see the application act as both a producer in the first step and a consumer. Similarly, the billing service is doing the same. That is one of the things you need to always pay attention to, because all the processing is done in an asynchronous messaging fashion. There is no response to be immediately received, no request response model anymore. So that's how we usually handle if we want to receive a response and send it back to some interested party. That's it, guys, in a nutshell.